Good morning, and once again, welcome to my YouTube channel, Math with Ease. And in this video, I want us to learn how to get the surface area of prisms. And we are going to start with a triangular prism. As we understood that a prism is a solid that has a cross-section. This triangular face is a cross-section, meaning that if you keep cutting along this line, you will maintain the same shape till the end. So this is the cross-section of face, and this is the height. The best way to calculate the area of a triangular prism is to open it up as a net. And I just want to have this net now opened. But before we open, there is this base. There is a base of 8 centimeters by 12 centimeters. That one goes, it's the base. It's actually the base. That is the base. And on this side, we have a flap, the triangular flap, which is having another identical triangular flap. And there is this face we can see if we have to have A, B, C, D, E, and F. There is face B, F, D, C. B, C, D, F. It will come here. And the length, its length is 12, because this is 12. And the height we are going to calculate. There is that other face, that is face A, F, D, E, which comes here now. A, F, D, E comes over there. And this is F, this is A, and now this is D, and this is E. Now you realize that if you close up this net, this point will connect to this point, and even this point is point F. And this point is going to connect this one, so this one is still a D. And this one is D. And this one is F, because they will close that way. So we have a triangle whose height is 3. You can see if we just extracted that triangle, we will enlarge it here and calculate its area. This is 8. The whole of this is 8. There is a perpendicular height which is 3. And that means that is equals to that as provided in the figure. And that means that side is equals to this. So 3 centimeters from here to here, because this perpendicular bisector bisect this line AB into 2 equal parts, then this is 4 centimeters. Using Pythagoras, we can easily say 4 squared plus 3 squared is equals to, let's call this hypotenuse squared. And it goes without saying, this is simply 16 plus 9 is equals to h squared. And we can already say that h squared is equals to 16 plus 9, which is 25. And h is the square root of 25, which is 5 centimeters. So this height, which we can call FB, FB is 5 centimeters, 5, 5, and 5. So that is it. And even this is now 5. And this is 5. And this is 5. And this is also 5. And this is 12. Now, the area of the whole area becomes, let's have the flaps first of all, this triangular flap and this triangular flap, and there are 2. So the triangles themselves, the triangles are half times the base, which is 8, times the height, which is 3, times 2, because there are 2 triangles. That and that cancel out, and we have 24 centimeters squared. Now, we are done with that. We are done with that. Let us now come to this rectangular face. 12 times 5. This is simply, this is going to be triangle, let's call it triangle rectangle A, which is 12 times 5, and there are two because we have this one. This is another A. The length is 12, the height is 5. Remember, the height is equal to the hypotenuse of the triangle. So times 2. This is 10 times 1, 12, which is 120 centimeter squared. And then we get to the triangle B, which is actually the base, which is going to give us 12 times 8. Remember, this is 8, the base of the triangle. 8, 8, 12 times 8. Rectangle B, which is 12 times 8, and it's just 1, so times 1. 12 times 8 is 16,896. Now you have all this, you add together. This is going to be 4, this is 0, carry 1, 3, for 5, 3 plus 2 we have 5, 5 plus 9 we have 14, carry 1 plus 1, which is 240 centimeters squared. So the surface area of that triangular prism is 240 centimeters squared. In the same video, let us talk about the surface area of a circular prism. The surface area of a circular prism, something that looks like this. The circular prism with a radius of 7 centimeters and a height of 14 centimeters. Again, the best approach to this is to open it up as a net. And this one is going to be quite interesting because once you open up, you'll have a circle at the top and you'll have a circle at the bottom. And once you open up a cylinder, if you cut it like at that particular point, you will open up and this becomes a rectangular. This becomes a rectangular shape. The curved surface becomes a rectangular shape. The height remains 14, but if we say this is point A and this is point B, if we fold this point A along the circumference of the circle, and then this edge along the circumference of the circle, you will find that the point A will meet with the point B at this particular point. So basically, this is also point A. Once folded back, it will form what we call circumference. So this length, basically, it is the circumference of the circle. And how do we get the circumference of the circle? 2 pi r. First of all, let us get, this is 7 radius, and this is 7. Let us get the bottom, top plus bottom. What is the area of a circle? Pi, which is 22 over 7, times r squared, which is 7 squared. Of course, times 2. And that is it. So pi r squared times 2, you get this is by 7 1. You will have this is 49 divided by 7 is 7, and then 22 times 2 is 44 times 7. This is 28. Carry 2, 28 plus 2, that is 308 centimeter squared. Now, we still have the rectangular part, which is 22 over 7, 2 pi r times 2 times the radius 7, of course, times 14. 2, because this is the length, times the height. 2 pi r times the height. 7 1 by 7 1. And we have 22 times 2, which is 44. And we are going to have 44 times 14. 44 times 14, which is 4, 4. And 4 times 4, 16. Carry 1, 16, 17. And this is 6, 1. 6. Now, the total area becomes 308 plus, this is 16, carry 1, 16, 17, and this is 6, this is 11, carry 1, 4, 6, plus 616. And the entire surface area of the cylinder or circular prism, 14, carry 1, 1 plus 1, 2, and then 9. We have 924 centimeter squared. And that is the end of that video. Subscribe and of course hit that bell so that every time we have new videos, you'll be the first one to be notified. Thank you.